A huge thank you to Toby Maguire for the beautiful introduction. Hello everybody, this is Mr. Salgado with a new video that you will need to complete the notes for our new section, which is running water. If you remember, our previous section was weathering, and right there we talked about, how we can break rocks down into little pieces through mechanical weathering, and we also talked about changing rocks into new substances through chemical weathering. So, okay, you have your rock, you break it down into little pieces. What's gonna happen now? What's next? Well, the quick answer is that nature is going to transport those pieces of rock somewhere else. And what is nature going to use to transport those pieces somewhere else? Well, one of the main things nature is going to use is water. So that's why our new section is called Running Water. And for us to understand how nature transports all these pieces of rock, we have to understand the water cycle. So that's exactly where we are going to start. So now you guys might recognize this question from one of the Bellworks, and it says, how many times does a water molecule go through the water cycle? And this question was meant to help you guys realize that the water cycle is a never-ending process. It just keeps going and going and then happening. So the water cycle is the unending circulation of Earth's water. So I have a picture right here, and in class I try to make the joke that the same water that the dinosaurs were drinking thousands of years ago is the same water that we're drinking today. So I have the definition for cycle here. So a cycle is a series of events that are regularly repeated in the same order. So right here, the water cycle has some events that just keep repeating themselves over and over again. And what are those events? What are those steps? We have evaporation, we have condensation, precipitation, we have runoff, we have infiltration, and we have transpiration. So those are the main the ones that we're concerned with. And you guys already know those, but I'm just gonna very briefly touch each one of them, just so to help us review them. So let's start with evaporation. And evaporation does not only happen at the ocean, but it could happen on land. We have the evaporation of lakes, rivers, your pool, your fish tank. All water on the surface can also evaporate if provided enough energy. So what is evaporation? Evaporation is the conversion of liquid into gas. So liquid water becomes water vapor. And then, what do we have after? We have condensation. And what is condensation? Is the conversion of gas into liquid. So it's the opposite, right? So, you have the gas water molecules floating, and then they start getting together, and they make big enough droplets that are heavy enough for them to fall back down to earth or to the ground. Then we have precipitation. What is precipitation? Precipitation is just another word for rain, snow, sleet, hail that falls to the ground. And then once it rains, we have runoff, and runoff is water flowing over the Earth's surface. So the water is flowing in the form of rivers, and it's going to accumulate in lakes. Now some of the water on the surface is going to infiltrate into the soil. So we have this process called infiltration, which is the movement of surface water into the soil through cracks and pore spaces. So the water goes underground, and once it's underground, it might get picked up by a plant and then transpire back into the atmosphere through a process called transpiration. So what is transpiration? Is plants releasing water into the atmosphere. So transpiration is nothing but plants sweating. So now, in order for the water cycle to keep going, to keep repeating itself, it must have an energy source, something that keeps it going. And you guys already know this. The sun provides the energy to power the water cycle. Now there is another power that helps to keep the water cycle going, and it's the power of gravity. And gravity is mainly gonna work on this side over here. We're not going to talk about it right now, but we'll talk about it later in the video. So just keep it in mind, so it's the sun and gravity that power the water cycle. So as a quick side note, that whole research project that you guys just did about Rialto's drinking water, Well, so one of the sources for our drinking water is Lido Creek, which is, a small river right here in North Rialto. So we get some of our water from there. However, about 40 to 50% of our drinking water actually comes from groundwater, which is, water underground. So they drill wells and they pump the water out and send it to people's homes. Now, the whole deal with the BF Goodrich site is that at the site that we're making rocket fuels and fireworks, and, one of the main ingredients for those things is perchlorate. Now, somebody didn't dispose of the perchlorate properly. They just kind of left it on the floor, on the ground. So when it rained, the water took down with it some of the perchlorate, and that's how the perchlorate ended up in the water. They realized this. They realized that the water was polluted back in '97, and so in 2002 they started this whole campaign to clean the water. Now it's getting fixed. Okay. So now let's go back to the water cycle, and let's get a water molecule from the ocean. It's gonna get enough energy from the sun to become gas and go up into the atmosphere, and then eventually it'll go back down as rain and it fall back into the ocean. So now the water molecule ended up back where it started. So this water molecule just completed a cycle. However, what about this the water molecules that rain on land? They have to make their journey all the way back to the ocean, and we're gonna track that journey, their path back to the ocean. So we're gonna talk about streams and rivers, which is water making its way back into the ocean. Okay, so this is where gravity comes in, because with the help of gravity, streams and rivers will carry water downhill from the land back into the sea. So the water is making its way back to the ocean. Now, on the way back, the water is going to take a souvenir with it, and the water is going to erode, so it's going to transport the sediment, those broken pieces of rock is going to take them with them, and it's going to dump them somewhere else. So right here we have a picture of a river flowing, so the water is making its way back into the ocean, and as it's going back, it's taking down with it rocks and pieces of rock. So one of the main characteristics of a river, it's its velocity, because the greater the velocity of the stream, the more sediment it's going to be able to transport. The more pieces of rock is going to be able to transport. So now there's different things that are going to affect the velocity of a stream. So let's take a look at what's going to make a river flow faster or flow more slowly. Let's see what is it. So okay, there's three factors that are going to determine the velocity of a stream, and they're gradient, channel characteristics, and discharge. Now the first one, gradient, it's just another word for slope or steepness of a stream. So we have a river right here, and right here we have a very steep gradient, and right here we have a very small gradient because it's flat. So now the question is, where is the river going to have the most energy? Is it going to have more energy over here, or is it going to where it's steep, or is it going to have more energy right here where it's flat? And if you guys look at the size of the particles that it's carrying, these particles are much bigger than this one. So therefore, we can conclude that the steeper the gradient, the more energy the stream will have. So it can transport bigger pieces of rock. Right, so so the steeper there is, the more energy, maybe the more velocity that the river can have. But that's not the only thing that is going to influence whether a river or stream would be fast or slow. We also have to look at the channel characteristics. We have to look at the shape, the size, the roughness of the channel. So the channel, is the little thing that gets carved, that the river carves. So the river channel. Because the channel, the roughness of the channel is going to affect the amount of friction between the water and the ground, and therefore it's going to affect the velocity of the river. So right here we have the water flowing, and first of all, before we talked about the channel characteristics, the question is where are we going to find the fastest moving water? Are we going to find it right here at the bottom, on the sides, or at the center? Well, if you look at the water right here that's flowing at the center of the stream, you can notice that the water is not rubbing, is not touching anything. So therefore, right here, the water at the center of the stream, at the center of the channel, is gonna move the fastest. Right here, the water at the bottom is obviously rubbing against the bottom of the channel. So that friction that is caused is gonna slow down the stream. Okay, so you know, you always have your fastest moving water at the center. Now let's compare this small stream to this bigger one. You know, which one is gonna be faster? Okay, so this one, if you notice, the amount of water that it has is very small, and because it has a little bit of water, most of its water is touching the ground, the channel. Therefore, you know, there's a lot of friction between the water and the channel, and that friction is gonna slow the flow of the water. So this river is gonna be very slow. It's gonna have a small velocity. Now, let's look at this one and look at the quantity. Look at the amount of water that is not touching the bottom of the channel. You know, it's a huge amount of water. So therefore, this channel is going to be faster because most of its water is not rubbing against the bottom of the channel. You know, it has a big amount of water. So, you know, compared to those two, this is going to be the faster channel. It's going to have more velocity. So now the next thing is the discharge, and discharge is the volume of water flowing past a certain point in a given unit of time. So let me put this picture back up. And for this, all you need to know is that the bigger the discharge, the bigger the velocity. So once again, you know, this river, it's bigger, so it has a bigger discharge. You know, it's dumping more water. Now, here's where it gets a little bit confusing, because if you look at a river that is flowing down a mountain, you know, we know that at the top of the mountain, the mountain is very steep, and at the bottom of the mountain, you know, it's going to be very flat. So, you know, the question is, okay, is water at the bottom of the mountain gonna flow faster than water right here at the top of the mountain? And you know, logically, you would be inclined to say that water at, you know, right here where it's very steep is gonna flow faster. However, that is not true, because okay, look at the size of this river, the stream. You know, it's very small. It has a little bit of water, and because the stream is so small, most of its water is rubbing against the channel. So there's a lot of friction, and all that friction is gonna reduce the velocity. So this river, the stream at the top of the mountain is gonna have it's gonna flow very slowly. And right here, even though it's flat, there's not a lot of friction between the water and the channel. So therefore, the water is gonna flow faster at the bottom of the mountain. And I'm seriously, it's kind of confusing, but you know, that's how it is. The last thing that we're gonna talk about is the stream profile. You know, the best way to study a river or a stream is by looking at their profile. And what is a profile? Is the cross-sectional view of a stream from its source to its mouth. So, you know, we always call the beginning of a river the head, and we always call the end of the river the mouth of the river. So, you know, this is the profile. And you know, one of the things that you notice is that, as you know, right here we have a big gradient, and right here we have a small gradient. So as the gradient decreases, the discharge is going to increase. You know, by looking at the previous picture, you know, we said that the discharge at the top is going to be very small. You know, the river is dumping a little bit of water, but as you get to the bottom, you know, the river is going to dump a lot more water, because you know, it has all these tributaries that are contributing water to it. So this is pretty much it. You know, if you guys have any questions or anything that wasn't clear, you know, just bring your questions to class, and you know, I'll be happy to address any confusions. Okay, so have a good night. Never mind the good night. I forgot to mention one last thing. Is okay. So how do we know that our water cycle is balanced right here on Earth? And that's pretty simple. You know, we can find evidence that the water cycle is balanced because we look at the level of the ocean, and you know, the level of the ocean hasn't changed very much. So because the amount of water that leaves the ocean eventually makes it all the way back, you know, through a river, or through rain, or underground water. So you know, this is the ocean level is evidence that our water cycle is balanced. Okay, so now have a good night.